Hello friends, I am Amiranul Nizami and today we are going to study a basic code ABD matrices for the laminated composite plates. Basically, we have read already the various classical plate theories, first order shear deformation theories and all, but some of the viewers have asked that sir, I am not getting the basics as I haven't covered. So they have asked for making a uh, lectures on the ABD matrices. Okay, so for the laminated composite plates, basically for in the classical laminated theory, we have just made the ABD matrices. Okay, so how we code for it? So from the JN Reddy book, they have asked to solve some examples. So we will try to solve that. Okay. So first of all, if suppose it is a lamina, and this lamina is is made of two parts. One of them is this is the fiber. Okay, the fiber. These all like cylindrical are the fibers and fibers, and these are the matrices, a matrix. Okay, so the composition made from combination of matrix and fibers are called the lamina. So it is a one plate which is lamina or a layer. Okay, and when various layers or lamina are arranged together, they are called laminate. Okay, or the plate, laminated plate or composite plates. Basically, in a laminated composite plates, a lot of layer are oriented here. Okay, they are made up of several layers or lamina having different stacking sequence. Okay, it may have 0 degree, 90 degree. Okay, suppose this is 0 degree angle, then this is 90 degree, then again 0 degree. So in this way it can have, or maybe 30 degree. Okay, minus 30 degree, then plus 30 degree, or any other sequence can be possible. Okay, so we will see how the constitutive matrices of a lamina is written. Okay, so we will just go to one of the PDF from the JN Reddy. So he has very well explained the plate stiffness coefficients. Okay, so here it is already written that in the material coordinates for the orthotropic plate, principal material axis x1, x2, x3 coinciding with the plate coordinates. Okay, so when the orthotropic materials with principal material axis coincides, okay, means uh, the plate coordinates and the material axis both coincides with each other, or you can say especially orthotropic plates. Okay, then this sigma xx, sigma yy, sigma xy would be equals to this matrix, constitutive matrix, times the strain. So this alpha times delta T is the thermal strain. So we are not talking about thermal, we will neglect it here right now. We can place zero value for that. Okay, so we are only interested in axial strain or the mechanical strain only, not the thermal. So Q11 is E1 upon 1 minus nu12 nu21. Similarly, Q12 and Q22, Q6 are given. Okay, in terms of the Young's modulus along the fiber direction E1. Okay, E2 is the transverse to the fiber directions. Okay, and so on. And nu12, nu21 are the Poisson's ratio, and G12 is the shear modulus. So when this would be arranged, then we can say sigma xx, sigma yy, and sigma xy can be transformed. Okay, in the plate axis, because it is not necessary that it may be of arbitrary angle theta. Okay, it is not necessary that the coinciding of the material axis and the plate axis. It's not compulsory. Okay, so it may be possible that it may not coincide. Okay, so therefore any arbitrary angle, so we will get this matrix, okay, sigma xx, sigma yy, sigma xy by getting the transformation matrix, and this transformation q11 bar, q12 bar, q16 bar is written here. Okay, these are the transformation. So it would get q11 bar equals to q11 cos 4 theta plus 2 times this plus so on. So you can see from here the formula, and then we are neglecting alpha xx because it is a thermal coefficient. We are not interested right now here. So now we will see that okay, the plate constitutive equations relate to the forces and moments, and we are related with we are interested to get these forces and moments. So therefore, when we will get the resultant forces or resultant moments, when we will integrate this stresses sigma xx yy xy with respect to throughout the thickness minus h by 2 to plus h by 2, we will get the uh, forces. And similarly, when we will get the moment when we will integrate this stress times z into dz. So this we are multiplying, okay, stress, then we will get the bending moments. So now we will see the code, and we will also uh, try to code it. Okay, so aij dij matrix how we get, and here it is not written the bij matrix because it is assuming that that matrix due to the symmetric way it is 0. Okay, so now we will see the examples from this book. So here aij and dij matrix is given, q11 q12 formula is also given, and these are the plate. Okay, various lamination are shown here. Okay, so 1 2 3 various layers are stacked together. And the first examples, what it is saying that okay, consider a plate made of graphite epoxy, and Young's modulus and all are given here, Poisson's ratio value, and the elastic coefficients qij in the principal material coordinates. So what would be the value of qij? Okay, if Young's modulus are given, then we want to find the coefficients. So let's start with the Matlab code. First of all, what we have written here, so we have written the basic that okay, how much layer it is composed of. A laminate is composed of maybe various lamina. Okay, so how much lamina, we have to put the value 1 2 3. Okay, it may be a single lamina or it may be 5 10, any number of lamina. Okay, then this E naught is not interested because it's only for the normalization value, and these endpoints number of points are used for the plotting purposes. Okay, here now we are interested in knowing the geometry of the plate. So what's the geometry? So what's the total thickness or total height of the plate? Okay, when we will get the total height of the laminate, when we will sum up all the single lamina thickness. Okay, now h we are imposing that okay, total height, if the total height of the plate is given, we will divide by 2, then it would be h, and h1 we are taking that total height of the laminate or total height of the plate. Okay, now length along the x-axis of the plate is 1, and length along y-axis is also 1. Means we are taking a square plate. Now, further, we are having the interfaces of the laminated plates. So what are the various interfaces of the laminated plates? How we will get? So right now we have seen here. Just above that these are the interfaces at this position. These are the interface. These are the interface. Okay. Similarly, these are the interface. These are the interfaces. So these are the interfaces. So we want to get the coordinate of the interface. Okay. So we will calculate the layer interfaces. This is a function made, okay, to calculate the layer interfaces, and the input it wants the total number of layers and the thickness of the plate. So therefore we will get the location of the inter layer or layer interfaces. Now we are given the material properties. Okay, E1 equals to 20.6, E2, G12 and all. Now what it has asked, the first examples, we can see that they have asked for the elastic coefficients Qij in the material properties. So first of all we have to find Qij. So we will see that okay, we are getting or not. So we will just run the code up to here. For this example, I think it has only for the single layer. So enter the number of composite plate lamina. We want single layer. And what is the height of the laminate? 0.001 inch. I think they have given in the problem. Look at, and only here Qij. So here it has mentioned H thickness of the laminate at 0.001. Okay, so we will give 0.001 only, 0.001. Then we will enter the thickness of first layer. So it would be 0.001 only. Yes. So now we will see. Let us just enlarge it. And what the first value Q11 is 2.0118 into 10 to the power 7. Let's see in the book. Okay. So 20.118 means it is completely matching, because it is given in MSI and we have already converted into the PSI because we have multiplied it with 10. Okay, 10 to the power 6 E6. So therefore we are getting this value. Similarly, Q12 is 3.922. So we will see it in the book also. So Q22 is 1.3. So Q22, let's see, Q22 is 1.30. Okay, so we can also see from here. Then Q12 is 0.3923. Q12 is 3.29 into 10 power 5. So 0.392. Okay, so we are getting the value of Q11, Q12 and all. Now let's see the second problem, what it has asked. So if the plate thickness is this, then A11, A22 also. So let's find out A11, A22. Then we will see that, okay, up to this much we have run the code, and A11, A22 means ABD matrices. So now how we will proceed further after this? Let's proceed. So these are the coordinate points. So right now we are not going to plot anything, so it would not be of much use at this position. So now from here we have initialized some zeros matrices. Okay, A matrix, B matrix, and D matrix as some Aij and so on. Then we can do one thing. We should cut it here, and we should do it here. It should be kept here. Okay. Now this is the transverse loading position, but here we are not going to load right now anything, so it is not of use. And layer orientation scheme or stacking sequence. So what are the layer orientation scheme? So right now only one plate, so no other stacking sequence are required. So therefore it will take the number of layer as 1 and it will do itself. Now we are going to produce ABD matrices. So how we make ABD matrix? So we have seen that if we are knowing the Q11 bar and so on, then we will see, okay, Q mat 1 equals to this matrix Q11 bar, Q12 bar and so on, as we have seen the formula from the book. Okay, so Q11 bar, Q12 bar, here it was written. Okay, this Q11 bar equals to Q11 cos 4 theta and so on. So we have just copy pasted it. Okay, from here we have taken this formula and here we have written, okay, from this Q11 bar it is written here, and hence Q4, 5 and all, it is a shear part. It has not considered here because it is classical plate theory, so it's not required. Now we know Aij matrix, so we can solve it, the Aij matrix here. So what would be the Aij? Aij would be, let me show it here. So it is directly showing the formula Aij equals summation of k equal to 1 to number of layer Qij Zk plus 1 minus Z. So we have just written here Q mat 1 is the Qij matrix, okay, and multiplying ZLK plus 1 next lamina to the subtracting the previous layer of or interfaces of the lamina. Okay, so this would be the Aij, and then it is here loop. We have applied a loop k equals to 1 to number of layer, so it will come again and then add up and so on. It will make the Aij matrix. Similarly, Bij matrix would be made, and then Dij matrix here 1 by 3 of this. So then finally, after number of layers, it would get some added up, and then we will get the A matrix, B matrix, and so on. So now we will see the ABD matrices. So we will just stop here and run the code ahead. So let's continue running. So it is asking the orientation of the lamina. So only single layer, so no orientation, 0 degree. So let's see. It is not required further, but we will see before. Yes, we are getting as Q matrix is this, A matrix are here 2.0118 and so on. B matrix is 0, okay, and D matrix is this one, okay. Then we are getting n vector mean nxx, nyy, and nxy. Here it's written nxx, nyy, nxy, and then m vector means bending moment mxx, myy, and mxy. Okay, so here it is written. Okay, so here we are getting the above value in the numerical way. Okay, here it's a rational value. So what we have to do here, we'll see where nxx, nyy, nxy is given. What we have done there, we have taken the double. We have applied a command double. Okay, but in bending moment, when we are calculating bending moment m vec, so I think shift m vec we have to take it, and now it will give us the correct value. It's not required. Yes, now it is giving us mxx, myy, and mxy value. Okay, so we have got the results. We will see here. Mx A matrix and D matrix are given here. B is already 0, so it's not required to see. So here we are having D matrix 0.0017 and so on. So the same is given here. Okay, D matrices and all. Now you can see this A matrix is given for 0, 90, 0 degree. Okay, so its number of lamina is changing here. Okay, so you can change also, and similarly here it is given for 60 degree. So if the laminate is oriented at 60 degree, then what would be the Q value, A value? So we can play with it now. We can have any value. We can run it. Let us do one thing. Let me pause. Now we will run the code again. Okay, enter the number of composite plate lamina. Let's consider the second problem, how much it is considering. This much. If the principal axis are oriented at 60 to the plate axis, then we have, okay, so 60 degree orientation. Let's see, enter the number. Let's have one plate. Enter the height of the laminate 0.001. So first layer is same, so total 1, So Q matrix is given here. So let's see whether it has given Q value. Yes, for the 60 degree it is given here. You can see for the 60 degree it has given here. Q11 bar is 2.9125. So here Q11 2.0118. So it's almost same value. Q22 bar, how much it is? 12.318. 1.3076. Okay. And A matrix and D matrix, let us calculate. Further we will run it. Enter the orientation 60 degree. So here A mat and D mat are also given. Okay. So we will continue with it. So we are stopping here.